Let us look at question number 25 now, students. The number of electrons present in bonding molecular orbitals of N2, O2, Cn minus and NO plus are U, V, W and X respectively. The value of U plus V plus W plus X is equal to. Students, if we talk about N2, so in N2, if we talk about the bonding orbitals, so we have sigma 1s2, we have sigma 2s2, we have pi 2px2 is equal to pi 2py2, and then we have sigma 2pz2. Okay. So if we talk about the total number of bonding electrons, students, the total number of bonding electrons present in N2 is equal to 10. Okay. If we talk about O2 now, students, so for O2 also, there will be a total of 10 bonding electrons present. So the value of V is also equal to 10. The value of U was also 10. So O2 and N2 will have the same number of bonding electrons. Okay, if you talk about Cn minus, so Cn minus is again isoelectronic to N2. So it is also going to have 10 electrons in the bonding molecular orbital. So the value of W is also again equal to 10. And lastly, if we talk about NO plus, so NO plus is also isoelectronic to N2. So it is also going to have the number of bonding electrons equal to 10. So the value of X is also equal to 10. Students, all of these given numbers are equal to 10. U is 10, V is 10, W is 10 and X is also 10. So the sum will come out to be equal to 40. Okay. Let us look at the next question now. Let us look at question number 26, students. A mixture of FeO and Fe2O3 when heated in air to a constant weight gains 8% in its weight. Find the percentage of Fe2O3 in the given mixture. So students, if we talk about the mixture which is given to us, students, we have FeO and Fe2O3 and it is allowed to react with air. Students, when this mixture is allowed to react with air, it is only FeO which is going to react with oxygen and it will convert into Fe2O3. Okay. So we can now balance this reaction, students. 2 FeO will react with half O2 to give us 1 Fe2O3. Okay. Now it is told to us that the mixture gains 8% in its weight. So if we assume that the mixture be weighing 100 gram and we can assume that X gram be FeO, so we can find out the value of X from this balance equation. Okay. So it is given to us that 8% weight is gained. So students, it means that if the mixture was 100 gram, initially the final weight was 108 grams. Okay. So out of this 108 grams, it is obvious that the mass of oxygen which is added to the given compound is equal to 8 grams. So we have 8 upon 32 moles of O2. So this is equal to 1 by 4 moles. So the given mixture reacts with 1 by 4 mole of O2. It means that the moles of FeO should be equal to 1, as 1 mole of O2 will react with 4 mole of FeO. So 1 by 4 mole of O2 will react with 1 mole of FeO. So the given mixture of 100 grams contains 1 mole of FeO. It means that the mass of FeO present in the 100 gram mixture is equal to 72 grams. Okay. So students, the mass of FeO is 72 grams. It means that the mass of Fe2O3 in the mixture should be 28 grams. And if we talk about the composition or the percentage of Fe2O3, it is going to be 28%. So students, for this question, we have to mark the correct answer as 28. Okay. Let us look at the next question now. Question number 27. Mendeleev's form of periodic table had left some space vacant for elements yet to be discovered. The atomic number of Eka silicon in the modern periodic table is. So students, if we talk about Eka silicon, so Eka silicon was supposed to lie below silicon in the periodic table. So we know that the element that lies below silicon is germanium. So germanium is Eka silicon and its atomic number is equal to 32. Okay. So students, for this question, we have to mark the correct answer as 32. Let us look at the next question now. Question number 28. Wavelength of high energy transition in H atom is 92 nanometers. Calculate the corresponding wavelength in nanometer for He plus ion for the same transition. Okay. So students, we know that energy or change in energy, which is delta E, it is proportional to Z square. So students, if we talk about, so if we assume that the delta E for hydrogen be E, then the delta E for He plus shall be equal to 4E. Okay. So atomic number of hydrogen is 1, whereas the atomic number of helium is 2. So when we square the value of 2, we get 4. Okay. So students, the delta E for He will be equal to 4E, and we know that the delta E is inversely proportional to lambda. Okay. So if we talk about the lambda for He plus, okay, it is going to be equal to lambda for H upon 4. So students, the lambda for H is given to us. It is equal to 92 nanometers. So the required lambda for He plus shall come out to be equal to 23 nanometers. Okay. So students, for this question, we have to mark the correct answer as 23. Let us look at the next question now. Question number 29. A mixture of CaCl2 and NaCl weighing 3.7 gram is treated with Na2CO3 solution to precipitate all the calcium 2 plus ions as CaCO3. The calcium carbonate so obtained is heated strongly to get 0.84 gram of CaO. What is the percentage of NaCl in the mixture? Okay. So students, we have a mixture of CaCl2 and NaCl. So this is allowed to react with Na2CO3. So what happens is CaCO3 is precipitated from the solution. Okay. Now it is given to us that the CaCO3 which was precipitated, it is heated and it gives us 0.84 gram of CaO. Okay. So we know that when CaCO3 is heated, it gives us CaO along with the liberation of CO2. Okay. So the grams of CaO is given to us. It is equal to 0.84 gram. Okay. So what we can do here now is that we can find out the moles of CaO, and using the moles of CaO we can find out the moles of CaCO3, and using the moles of CaCO3 we can find out the moles of CaCl2. Okay. So basically we have to apply the POAC on the calcium 2 plus ions. Okay. So let us first try and figure out the moles of calcium present. So moles of calcium 2 plus ions present is equal to 0.84 upon the molar mass of CaO, which is 40 plus 16. It is equal to 56. Okay. So we can clearly see that the moles of CaCl2 will also be equal to this number itself, students. And if we talk about the mass of CaCl2 present in the mixture, this number of moles has to be multiplied by its molar mass. So the molar mass of CaCl2 is 111 grams, students. So if we talk about the mass of CaCl2 present, it is 0.84 into 111 divided by 56. Okay. So students, this on simplification gives us a number equal to 1.665 grams. Okay. So now we can figure out the percentage of NaCl. So we just have to subtract the mass of CaCl2 from the total mass to get the mass of NaCl. So we have 3.7 minus 1.665 upon 3.7 into 100%. Okay, this is the percentage of NaCl present in the given mixture. Students, this on simplification gives us a value equal to 55%. Okay. Students, for this question we have to mark the correct answer as 55. Okay. Let us look at the next question now. Let us look at question number 30 now. How many of the following have negative electron gain enthalpy? Okay. So if you look at the species which are given to us, we can see that there is beryllium present, there is magnesium present, and there is helium present. So students, out of these given compounds, beryllium, helium and magnesium, they have positive value for delta Heg. So if we talk about the other elements have a negative value of electron gain enthalpy, and they are 6 in number. Okay. So students, for this question we have to mark the correct answer as 06. Okay. Let us look at the next question now. Question number 31. Iodine molecule dissociates into atoms after absorbing light of 4500 angstrom. Okay. If 1 quantum of radiation is absorbed by each molecule, the kinetic energy per iodine atom is given by x into 10 raised to power y joules in the scientific notation. What is the value of x plus mod y? So the value of H, C and Avogadro number has been given to us. Also the bond energy of I2 is given to us. Okay. So students, if we talk about the energy of the photon, so the energy of the photon, we can call it as EP. It is given by hc upon lambda. Okay. So we can put the values of H and C. So it is 6.6 into 10 to the power minus 34 into 3 into 10 to the power 8 upon 4500 into 10 to the power minus 10. Okay, so this value will come out in joules, students. So if we simplify this number, we're going to get a value equal to 4.4 into 10 to the power minus 19 joules. Now if we talk about the bond energy of I2, students, the bond energy of I2 is given to us as 240 kilojoule per mole. Okay. Now students, we have to convert this kilojoule per mole into joules per molecule. So this will be equal to 240 into 10 to the power 3 upon the Avogadro number, which is given to us as 6 into 10 to the power 23. So this energy is converted into joule per molecule now. Okay. So if we simplify this value, students, we have a value equal to 4 into 10 to the power minus 19 joules per molecule. Okay. So students, now if we look at the energy of the photon and the bond energy of the I2, students, an excess of 0.4 into 10 to the power minus 19 joules is present in the photon. Okay. So we can see that the delta energy which is left is 0.4 into 10 to the power minus 19 joules, or it is equal to 4 into 10 to the power minus 20 joules. So this excess energy of 4 into 10 to the power minus 20 joules shall be given to the two I atoms. Okay, so each I atom will get a kinetic energy equal to 2 into 10 to the power minus 20 joules each. Okay, so this is the required kinetic energy, students, and it is represented as x into 10 to the power y in the question. So the value of x is equal to 2 and the value of y is equal to minus 20. So we have to report the value of x plus, so it will come out to be equal to 22. Okay, so students, for question number 31, we have to mark the answer as 22. Let us look at the next question now. Question number 32. A sample of hydrogen atoms having electrons in the ground state is exposed to high energy rays of quantum energy 13.3875 electron volt. Okay. The H atom absorbs the energy and gets excited. When the electron drops from the excited state to the ground state, how many lines are observed in the emission spectrum of the hydrogen? Okay. So students, we have to figure out the excited state to which the hydrogen atom reaches. Okay. So we have delta E. It is given to us as 13.3875. So this should be equal to 13.6 into 1 by 1 square minus 1 by n square. Okay. So if we simplify this equation for the value of n, we get the value of n equal to 8. Okay. So the excited state in which the hydrogen atoms are now present is n equal to 8, and when the electron de-excites from n equal to 8, the total number of lines seen will be 8 minus 1 into 8 minus 1 plus 1 divided by 2. Okay. So this is equal to 56 upon 2, which is equal to 28. So students, the total number of lines that will be observed in the emission spectrum is equal to 28. So students, for this question we have to mark the correct answer as 28.